Hello, and welcome back to another IB Math speedrun with me, Vince. In this speedrun, we're going to be going over homogeneous differential equations, so let's jump right in. So, what is a homogeneous differential equation? It's a differential equation that can be expressed in terms of dy over dx is equal to a function of y over x. And this is important because let's take a look at something that can be expressed in this form. Let's try and solve dy over dx is equal to 1 plus y over x, which would be impossible to solve with any of the current methods. And so in order to solve this, we need to use the substitution v is equal to y over x in order to solve this equation. How do we solve it? Well, let's rearrange this into xv is equal to y. And so if we differentiate both sides with respect to x, we get this is v plus x dv over dx is equal to dy over dx. So then we can substitute this part in to the upper part. So we have v plus x dv over dx is equal to 1 plus v. So we can cancel that. So we get more or less 1 dv over dx. 1 dv is equal to 1 over x dx. So we get that v is equal to ln x plus c. And then we can substitute back v equals y over x. So y over x is equal to ln x plus c. So we get that y is equal to x ln x plus some constant times x. So let's use this to solve some of the questions. So the first question is, we have xy prime is equal to excuse me, x squared cosine x plus y. So we can use y prime is equal to x cosine x plus y over x. So we use substitution v is equal to y over x. And so therefore again, xv is equal to y. And so we have v plus x dv over dx is equal to y as dy over dx. So we have v prime x, so xv prime plus v is equal to x cosine x plus v. Cancel these out. So we get v prime is equal to cosine x. So v is equal to sine x plus c. So again, resubstituting, we have y over x is equal to sine x plus c. So y is equal to x sine x plus c times x. Yeah. So that was cool. And then we can move on to the next one. And the next question is, we have x squared dy over dx is equal to y squared plus 4x plus xy plus 4x squared. So we can divide, I think, both sides by x squared. So we have dy over dx is equal to y over x squared plus y over x plus 4. So we have v is equal to y over x. So we have, again, we can substitute here. This is going to be v plus x dv over dx is equal to v squared plus v plus 4. Cancel the v's out. So we have x squared dx is equal to v squared plus 4. So dv v over dx is equal to v squared plus 4 over x. So if we divide both sides by v squared plus 4, we get 1 over v squared plus 4 dv is equal to 1 over x dx. And so can we do partial fractions here? I don't think so. Let's think. So we can use the tangent substitution. We can say u is equal to tangent of v. So we have du over dv is equal to secant squared v. So if we integrate this, we have 1 over tangent squared plus 4. Wait. Oh, sorry. I need to make this 2 tangent v. 2 secant squared. So we have 1 over 4 tangent squared v plus 4 times, which of course this is equal to 4 secant squared v, since secant squared is equal to tangent squared plus 1. So we have 1 over 4 secant squared times 2 secant squared, which is simply going to evaluate to 1/2. So we have 1/2 dv is equal to I mean 1/2 du, sorry. Ooh, this is getting a bit complex. 1/2 du is equal to 1 over x dx. So we have 1/2 u, which is of course u is equal to 2 tangent v. So 1/2 times 2 tangent v is equal to ln x plus c. So we have v is equal to the arctan of ln x plus c. So, oh sorry, no, I think I flipped it around. I think yeah. Whoops, sorry, no. This is supposed to be tangent to the -1. In other words, v equals tangent u. So dv over du is 2 secant squared u. So this is 1/2 du. Yeah, sorry. So this is 2 tan to the -1 v. So v equals tangent ln x plus c. So y over x is equal to tangent of ln x plus c. So y is equal to x tangent ln x plus c. So yeah, that is correct, I believe. And so now we can move on to the final one. Actually, sorry, no, it's 2x because of the substitution over here. So this should be 2 times that. Yeah. And so the final question is solve y prime is equal to y over x plus y squared over x squared for y if y of 1 equals 2. So in this case, we have to substitute v is equal to y over x. So we get v plus x v prime is equal to v plus v squared. Cancel these two out. So we get dv over dx is equal to v squared over x. So we have 1 over v squared dv is equal to 1 over 1/2. Oh, sorry, is that 2? No, this should be x. Sorry. Is equal to 1 over x dx. So 1 over v squared, this can be simply evaluated as -v to the -1 is equal to ln x. So we have -x over y is equal to ln x. So we have y is equal to negative x over ln x, I think. Is that it? It's a bit different. What have I done? Plus c for y of 1 equals 2, of course. So we have ln x plus c. So we have, when y is 2, x is 1, so negative 1/2. It's equal to ln 1, which is 0 plus c. So your c is equal to negative 1/2, which does complicate matters a bit. So we have negative 1/2. So we have y is equal to negative x over ln x minus 1/2, which is of course equal to 2x over 2 ln x minus 1. I mean, this part, or we can invert this part, so we have 2x over 1 minus 2 ln x, which is how the book writes it. So yeah, that was all for the speedrun. I hope you enjoyed, and I hope to see you in the next one.